So we start with quality of services. Quality of services. And before we discuss quality of services, let's talk about the purpose of packet switch networks. So what do you think? What is the purpose of packet switched networks? So the purpose of packet switch networks is that they support all kinds of applications and data, including multimedia applications that transmits digitized audio and video streams. So the purpose of packet switch network is to support real-time applications, real-time applications, transmitting data, obviously, in terms of digitized audio and video. If it's a multimedia application, so if it's a multimedia application, then obviously it is sending data in the form of digitized audio and video. Okay, packet switched network also provides support to non-real-time applications. Okay, so if we talk about the real-time applications, real-time applications. So real-time application, the real-time application needs some sort of assurance from the network that data is likely to arrive on time. So real-time applications need assurance. Assurance from the network. For timely arrival of data. Timely arrival of data. Okay, but if I talk about the other type that are packet switch network support, that is non-real-time applications. So non-real-time applications can use an end-to-end retransmission strategy to make sure the data arrives correctly. And such a strategy obviously cannot provide timeliness. So whereas a non-real-time application uses end-to-end retransmissions. right? So why it uses end-to-end retransmissions? Obviously, yes, because we want data to arrive correctly at the destination. And yes, such a strategy cannot provide timeliness. Right. But the problem with such an application, with non-real-time applications having retransmissions, is that retransmission only add to total latency. So in order to satisfy the requirements of the real-time applications, we need to provide timely arrival, and the network components needs to play its role, right? So timely arrival must be provided by the network itself. And when I say network, this means I'm talking about the routers. The routers. Okay, so it should not be the job of the edge nodes only, right? So not just the edge node should be responsible for providing um, uh, timely delivery of the data. So therefore, the best effort model makes no promise and leaves this cleanup operation to the edges, and it is not sufficient for real-time applications. Therefore, the best effort model um, is not suitable or sufficient for real-time applications. Why? Yes, because best effort model uh, makes no promises, right? So that's why there is a need to there is a need to come up with a new service model. Why? Because the existing best effort service model is not enough to provide or fulfill the needs of real-time application. So this new service model can easily satisfy the requirements of non-real-time applications that were happily working with best effort service model. So this implies that the network will treat some packets differently if I talk about providing service to real-time application. So this means the new service model or the network based on this new service model uh, will treat some packets differently from the others. A network that can provide the different level of services. So a network providing different level of services is often set to support quality of service. So this means we need to come up with, in order to fulfill the requirements of real-time applications, we need to come up with a new service model that can treat some packets differently from the others, and having such a model or such a network providing different levels of services is set to support quality of services. So before we talk about the different approaches to quality of services, let's talk about the taxonomy of real-time applications so that we can identify the requirements correctly, requirements of real-time applications correctly. So now we would like to talk about taxonomy of real-time applications. So if I look at the application, we can have two types of application. One type of application is elastic in nature. Elastic in nature means such an application can afford delays. And the second type, the applications are real-time applications. So the real-time applications can further be subdivided into two types. One is intolerant, and the second type is tolerant. So there are applications that cannot tolerate delays in real-time application, and there are applications that can tolerate the variation in the network, in the network speed or the bandwidth. So this tolerant application, real-time applications can further subdivided into two types. One is known as non-adaptive. And the second type is known as adaptive. So adaptive applications adapt to the amount of delay that packets experience as they traverse the network, right? So whereas non-adaptive applications do not adapt to the delay in the network. So these adaptive applications can further be subdivided into two types. We have rate adaptive applications and then we have delay adaptive. So when we talk about the rate adaptive applications, so basically we are talking about video algorithms that can trade off bit rate versus quality. So these applications can trade off bitrate versus quality. And at the moment, we're talking about video algorithms. Okay, and if I talk the delay adaptive applications, these applications can adjust their playback point, right? So delay adaptive application means these applications can adjust their playback point. Okay, so this means we have variety of different real-time applications, and in order to satisfy the requirements of these different types of applications, or the rich space of application requirements also needs a richer service model that meets the need of any application